Okay, this is 1997, differential equations 10a. Okay, so what it says is if the y dx plus xy equals 0 and y equals 2 and x equals 0, find the two correct places decimals, the value of y and x equals 1. So what we're going to do is going to move both of these over one side. So we're going to get is the y dx equals minus x minus xy. Next thing we're going to do is factorize out the minus x. So we're going to get the y dx equals minus x into 1 plus y. Cross multiply the dx up and the 1 plus y down, because you're only allowed to have one on each side. Okay, so it's going to be 1 over 1 plus y dy equals minus x dx. Okay. Now, what we can do next is we can match up their limits. So we're going to integrate both sides. Now, it wants me to find the value of y when x equals 1. So I can put y here and x equals 1 up here, so that both limits match each other. Okay, and we also know that y is 2 when x equals 0. So that's me pairing off my limits. Okay, next thing I gotta do is go integrating it. Now, the integral of 1 over x dx is ln x. Similarly, the integral of 1 over 1 plus y is ln 1 plus y. So this here is going to be ln 1 plus y, close bracket. Okay, integrate minus x, and that's from y to 2. Okay, then we're going to integrate ln x, which is going integrate minus x, which is going to be minus a half x squared, because you have to add on a power. So you add 1 onto the power, and then you divide by that number you just turned it to. So half minus a half x squared. That's from 1 to 0. Okay. Next part of that is going to be ln 1 plus y, because you're substituting the y limit in here, and then you're going to take away the 2 limit. So it's going to be minus ln 3. 1 over y minus ln 3, and this here is going to be minus 1, and then it's going to be minus 1 times 0 squared. Okay, now use your log rules for this part here. It's the first one minus the second one, which equals the first one divided by the second one. 1 over y over 3 equals minus a half. Now, please remember that means log to the base e. That's what ln means. Okay, ln means log to the base e. So, what you gotta do with logarithms is whatever's in here, that equals 1 plus y to the power of 3 equals e to the power of minus a half. Your whole goal of the experiment is to isolate y. So what we're going to get is 1 plus y equals 3 e to the power of minus a half. And then move to 1 over the other side. Y equals 3 e to the power of minus a half plus 1. Oh, sorry, minus 1. Excuse me. And once that's done, what you're going to end up with when you put that into your calculator is you're going to end up with y equals 0.8196 or y equals 0.82, corrected to 2 decimal places. Okay, are we happy with that? Okay guys, we do part B now. Okay, so that's end of part A. Now move on to part B. Okay, part B. There's the end of part A. Just going to be one second. Now, part B. A particle moves in a straight line and undergoes a retardation or deceleration of 0.04 phi cubed meters per second squared, where phi is its speed. Okay? If the initial speed of the particle is 25 meters per second, find its speed when it has traveled a distance of 26. Okay? So what we can say right away about this question is that for 10 big, we can say that the acceleration equals minus 0.04 phi cubed. Okay? Now, when it's travelled no distance, its velocity is 25. And then when it's travelled a distance of 49, we want to find out its velocity. So that phi equals big. Okay? Now, A... 97. Okay guys, A is the VDT. But the problem with the VDT is I haven't got any time limits. If I was to use time, I'd have t equals 0 and t equals t. And if I pair that off with V, you'll see that there's two variables there. That's not good enough. We haven't got any numbers to put in. So that's why we immediately know that we've got to go for we have to go for S and not T. So then we know that the rule for this is, it's going to be dVds by ds dt. Alright? And we know that ds dt is actually the velocity. That's the change in displacement or change in time. So it's going to be phi times the VDS, and that will equal 0.04 phi cubed. Now, what we can set up next is both our limits on both sides, pair them off. So we're going, one other thing I gotta do here, I'm not quite ready yet actually. What I also have to do is I have to make sure that I have S on one side and all the V's over the other side. So what I'm going to do is I'm going to leave the 0.04 over here. Yep.
How'd you know?
What we're going to do here is we're going to leave the 0.04 where it is, going to bring the phi cubed down. So we're going to have phi divided by phi cubed to V. It's going to end up to be minus 0.04 ds. Phi divided by phi cubed is 1 over phi squared. Or 1 over phi squared in turn is phi to the power minus 2. So that's what we're going to be left with there, okay? So everything that's come before it is now not really used anymore, so we can just bring this back up to the limits. Okay? So this is what we're working with now. And now I can put in my limits, okay? So blue here. Okay, so the 49 and the V are paired up, so it's going to be 49 and V, and what else is paired up is the 0 and the 25, so it's going to be 0 down here and 25 down here. So that's our pairing done on the integration, okay? 0 way around?
0 and 25 the other way around.
Oh, sorry, it is, sorry. Now that that's done, what we're going to do is we're going to integrate this, okay? Integrate phi to the power minus 2. It has to turn into phi to the power minus 1 because that's the power up from it. I need it to correct itself, so I need to have, it's going to be 1 divided by the new power. But 1 divided by minus 1 is in fact just minus 1, so I'm just going to put a minus 1 at the front. Okay, minus 1 phi to minus 1. I'm going to have phi and 25 here. Okay, and on the other side we're going to have what's it going to be, minus 0.04 s, and that's from 49 and 0. Okay, just reread the question again. I want to find its speed, okay, so I'm just going to find its speed here. So what I'm going to get is, when I integrate this, it's going to be minus 1 over V, because that's what this is. It's minus 1 over V. And when you put the first limit in, followed by the second limit, it's going to be minus 1 over 25. And then on the other side, we're going to have, that's 0.04 s. So 0.04 times 49 and then the second one is 0, so that's going to be basically minus 0 for the second one. Okay, find out what's happening. Minus 1 over v plus 1 over 25 is going to be equal to minus 1.96. We're going to try and isolate v. So minus 1 over v, bring the 1 over 25 over the other side, and it'll turn that into minus 2 when you add them together using the calculator. Then finally we're going to cross multiply, and we're going to get 1 equals 2v. v therefore equals a half. Okay, so that's our velocity. Now the next part after that is find the time for the speed to reduce from 25 to 15. 25 to 15. Okay, so what's going to happen here is we're going to do all the integration once again, and we're going to end it's time. Okay, so this question is a time question. Okay, so that's the important thing to remember, is it's a time question. Okay, so this time we're actually using the VDT. Okay, so if we start from scratch, okay, so this time we're not using feed to VDS, we're using the VDT. So what's going to happen is something like this. We're going to have A is going to get replaced with the VDT. The VDT is going to be minus 0.04 v cubed. Now the great thing is we now know our velocity to be 0.5. Now because we have a full information set on distance and velocity, we can now use a time information set. When the displacement is 0, the time, it hasn't moved yet, and then we can say that and it's 15 anyway, so sorry, excuse me, so that's all information anyway, so it's going to be phi equals 15. So the s is no longer matter, so it's going to be phi equals 15, because we're told at the end. So actually question 2 is completely unrelated to question 1. You could do question 2 without doing part 1. So 25 and 15, and let this be t, because we were looking for the time it takes to go from these two speeds. Okay, multiply the 0.04 v cubed down again, so we're going to get 1 over 0.04. Oh, sorry, and to be honest, leave the 0.04 where it was, because it actually makes it easier, right? So what we're going to get is 1 over v cubed dv equals minus 0.04 dt. Stop there. Bring in your integral signs and pair them up. So what we're going to get is 25 and 15. Now, yeah, that'll work, right? We'll just get a minus t and it'll still work out. Say?
That's fine.
Oh yes. So it's whatever way. I can mix the integrals whichever way I want once I pair them up properly. So t, we want to find out when the time is 15, so that'll be 15 up here, and when it's 0 it's 25. So there we go. Okay, now we're going to move on, and what we're going to get here is we're going to integrate this. That is phi to the minus 3. Phi to the minus 3. So when we integrate minus, it's going to turn into a minus 2. We have to have a 1 divided by minus 2 in front, so it's basically minus a half phi to the minus 2. Okay, and that goes from 15 to 25. Okay, and then on the other side we're going to have minus 0.04 t. And that's going to go from t to 0. Okay, we're going to integrate. So it's going to be minus 15 to the power minus 2 minus a half 25 to the power minus 2. And that will all equal minus 0.04 t. Okay, and then you're going to put all the left one into your calculator, and we can do it all in one go. That's the great thing here. Okay, this can all be done in one go, so there's no point in making it any longer than it needs to be. So what happens there, we'll get minus 8 over 5,625. That will equal 0.04t. Bring down, multiply both sides by minus, bring the 0.04 down, divide it in, and what you're going to get is t equals 0.0355 seconds. We want it to two significant numbers or 3 decimal places? It doesn't actually instruct me what to do, so I'm just going to just do it like this, 0.0, that's going to round up to 36.036 seconds. Okay, and that's 1997 complete.